have a situation where more than one factor could affect the response. Also, in analysis of variance, we could have more than one factor as well, and that is what we call multi-factor analysis of variance. Now, but the focus is actually going to be on the two-way ANOVA, where we got two factors. And of course, I'm actually going to walk you through how you can also determine that now. Okay. Now, like I said, two-way analysis of variance. Now, the first thing we want to talk about in the two-way analysis of variance, we want to look at the structure of the two-way, we want to look at the structure of the two-way data. How does it look like? And because of that, the example I'm actually going to be using today would be the two-factor is actually going to be subject. It's going to be subject and drug. And when we are presenting two-factor analysis of variance, we're going to have, cross tabulation where a particular factor is going to be in a row and the second factor is going to be in a column. Now, we are actually looking at the effect of certain drug. We want to look at the effect of certain drug on, on patient. And in this study, they actually believe that different patients have different body chemistry. With due respect to those who have lost families or who are impacted by the COVID, there are some people that catch COVID and they're able to survive with it, and there are some people that have COVID that died. So to tell you that different people have different body chemistry, and of course, you know that we have people that have pre-existing conditions. Okay, so my hope is that everyone that are impacted with the virus, either directly or indirectly, I believe at the end of the day we actually going to come victorious, against the virus. Okay, so right here we are looking at the effect of drug on patient, and we are also seeing subjects themselves as a potential factor. Now, if you in that situation, we're going to have the general average. This is going to be the general average, the grand average, which is going to be y bar dot dots. So the y bar dot dot, the two dots that you see there, one is actually representing the row, the other one is representing the column, because we got two factors that where one is in row and the other one is in column. Now, if you want to find, just like in the multiple linear regression where we can find the main effects of predictor, we can also find the interaction effect of the predictor. Now, as also in the analysis of variance, we can look at the effect of factor A and also look at the effect of factor B. Okay, and if I want to look at the effect of for either factor A or B, I need to first obtain this guy here, which I call the grand mean, which is going to be the mean of the response. Okay, and after getting the mean of the response, of course, then we can, if you take a look at this guy here, that is the mean associated with the factor A, and this is the mean associated with the factor B. Now, I'm actually going to walk you through an example right now. Take a look at this table right here. We have the subject are being categorized into 4 groups. Okay, these are subjects in group 1, these are subjects in group 2, these are subjects in group 3, these are subjects in group 4. Okay, and of course, the subject is actually factor A. Okay, and of course, if you take a look at the treatment is actually factor B. Only, like I said, the levels of factor A is 1 to 4, and the levels of factor B right here is 1 to 3. And what are the 3 levels of factor B? The placebo, the caffeine, and the trebomide. Can you see that now? Now, in this situation right now, the levels of one factor is not the same as the level of the other ones. Okay. Now, and what I have right here is actually the response. Okay. Now, this is a two. This is what I call a two-way analysis of variance or data layouts. Take a look at that. Can you guys confirm if you guys are still hearing me? Okay, so thanks for confirming that. Now, what am I going to do right now? I actually want to construct an ANOVA table. And you know what? If I want to construct an ANOVA table, what I'm actually going to do, the ANOVA table I'm actually want to construct is, is for two-way ANOVA table. But what I'm actually going to walk you through right now, I'm actually going to walk you through how you can, you know, compute this manually. And not only that, how you can implement that in R. Now, take a look at this right now. The very first thing I'm going to do, I need to first look at, get the drug effect. How am I going to get the drug effect? There are three levels of drug. I get the placebo, the caffeine, and the trebomine. Now, these are the estimated effects. Now, the question now is, how do I get 34? Okay, how do I get 34? Okay, 34 is just going to be, you're going to add all the data together from 11 to 32. You're going to add all of that and divide by the number. I think you're actually going to have like 12. You're going to add everything together and divide by the number. So that will give you 32. Okay, so the 32 that you're having now is actually going to be this guy here. It's going to be the grand mean that I talk about. Okay, that's going to be the grand mean that I talk about. Now, after getting the grand mean, the next thing now, how do I get the mean associated with factor A? Now, if I want to get the mean associated with factor A, I'm actually going to take you to that right now. Now, how do I get the mean associated with the placebo? The mean associated with that placebo is actually going to be 22. The mean associated with the caffeine is going to be 39. The mean associated with the trebomine is going to be 41. How do I go 22, 39, and 41? Now I'm actually going to take you to the data right now. Take a look at this. This is for placebo. I'm going to, extract out all the placebo. Take a look at that. And it means if I want to get the mean for placebo, I'm actually going to add 11 to 56 to 15 to 6 and divide it by 4. And that will give me the mean associated with placebo. If I want to get the mean associated with the caffeine, take a look at what I'm going to figure out all the caffeine. Take a look at that. I'm going to figure out all the caffeine and I'm going to add their values together and divide by 4. Okay? And if I want to have the mean that has to do with trebomine, I'm going to do the same. Okay? Take a look at that. I'm going to add all those values together and I'm actually going to divide by 4. And when I do that, of course, I will be able to, obtain 22, 29, 41 that I obtain right here. And after that, then I'm actually going to subtract the grand mean from each and every one of that. And what am I trying to talk about right now? Minus 12 is estimated effect of placebo. 5 is the estimated effect of caffeine. And trebomine is the estimated effect of, and 7 is the estimated effect of trebomine. I'm actually going to do the same thing to subjects. Okay, I don't need to recalculate my grand mean. My grand mean is 34 or 2. Okay, but the only thing I'm actually going to do right now is to find the mean associated with subject 1, the mean associated with subject 2, the mean associated with subject 3, and subject 4. How am I going to get the mean associated with subject 1? What I'm actually going to do, I'm going to go back to subject 1. Look at that is subject 1. I'm actually going to add 11 to 26 to 20. And I'm going to divide by 3. And that is going to be the mean, associated with subject 1. I'm going to do the same thing for subject 2. I'm going to do this for subject 2. For subject 3, I'm going to do the same. For subject 4, I'm going to do the same. Then I'm actually going to have the mean associated with each of these subjects. And of course, that is how I'm actually going to obtain, 19, 70, 30, and 17 that you have there. And of course, you're going to subtract the gram mean for each and every one of them. And after doing that, you're actually going to have the estimated effect for the subject. Consider now. And that is how you're going to get the estimated effect of the subject. Okay, so after getting the estimated effect of the subject, the next thing we can do right now, we're going to set up a table. And when you set up a table, you're actually going to write the first factor. After writing the first factor, then the three levels of the other factor. The three levels of the other factors is the placebo, the caffeine, and the trebomine. Okay, like I said, you are trying to cross tabulating right here. Okay, you are cross tabulating. You are cross tabulating. Subject, which is factor A, against factor B that have three levels. Take a look at that. That's exactly what we're trying to do right now. Okay, and of course, what I have right here. They are the data. You know that. Those are the data that we actually have. Take a look at the data 11 for placebo. And, if you take a look at this guy, 11 for placebo and for, subject 1. Okay, so we're just trying to reclassify that, and reclassifying that, of course, we're actually going to have what we have right now. And of course, don't forget that we have already obtained the mean effect of placebo, caffeine, and trebomine. How do we obtain all these guys here? We have obtained all those guys and all these guys. You know that? That was what we're trying to do right here. Look at that. That was what we're trying to get here. Look at that. We've been able to obtain all those ones, and obtaining that, then we're going to put them where they belong. Take a look at that right now. Okay, now, and what I have here is just going to be the mean. Okay, the mean of that and the mean of that, but we have been able to obtain the effect as well. Look at that, the effect of factor A and B. Okay, so in the calculation of effect, of course, you can actually, if you want what you got to make sense, then you actually gonna put them like this. Okay, this is the way you're actually gonna put them. Now, is there anyone of you who doesn't really understand how I set up this table? Is there anyone? Are you guys hearing me? Okay, so does that mean you guys are good up to this junction? Does that mean you guys are good with my explanation? Okay, so if all good, I think I'm actually gonna stop at this table today, and I'm actually gonna continue from here because I have some announcement to make. Number one, announcement to make concerning election, an announcement to make concerning the practical two assignment. So like I said, I'm gonna start from here today, and I'm actually gonna continue from here on Wednesday. This is not gonna be the end of the story because it's to continue until we get to the finally the ANOVA table and stuff like that. But you know what? I'm actually gonna walk you through this Wednesday. But I have a very crucial announcement to make concerning election and concerning, you know, practical two assignment. Now, everybody, you know that election is going on in the United States of America. And the United States of America is very, very important to the world. It's important to America, also important to it's important to Americans, also important to the world. Now, because of the fact that there's going to be election this week, and the practical two assignment